This is finding the inverses. And we're going to do this graphically and then algebraically on the back. So whenever we're doing this graphically, I find it best to use the TI calculators to get the table to get points when doing the graphs. You can get the vertex point from Desmos, but it doesn't give you a nice table with all the points in it. You can still use Desmos and find points by looking at Desmos. It's really up to you. The TI calculators are gone for the algebra test, Algebra 1 test that they're doing today, but on your either Android or Apple App Store, there's Calculator X. It's a free calculator. Looks just like the TI calculators. So you can use that. You can use Desmos. It's up to you. Okay, so remember the transformation formula or equation is f of x equals plus or minus a square root of x minus h plus k. And the h value, not including the negative sign, and the k value give you the vertex hk. Alright, and then of course then if it's negative you have a reflection. The A is a compression or a stretch. And H is going left or right. K is going up or down. That's just a reminder because this is something you definitely need to know this year. Alright, so looking at the first one, it says f of x equals 2 plus the square root of. So that's not in the same format as the equation that we started with. So I'm just going to take that 2 and I'm going to move it. I'm not changing anything, I'm just moving it to the end. So that this is f of x equals the square root of x minus 4 plus 2. So now I can clearly see my hk values. H is 4, because it's going to go to the right 4. So H is 4. And plus 2 means I'm going up 2, so the k value equals 2. And that is a starting point on your graph. So 1, 2, 3, 4. I'm also going to list that, so I'm going to have 2 tables of points here. So this is my f of x, my original. And I'm going to, you really just need 3 points, that's fine. I'm going to put my point 42 on my table. And the rest of them you can get from your table in the TI calculator, or you could go to Desmos and graph it and find points that way. So if you're using a TI, you do the y equals button, type in the function. So I have the square root of x minus 4 and then plus 2. And then if I do second graph, I'll get a table of values. So second graph. And for the first few points, it says 0 NA, 1 NA, 2 NA, 3 NA. There's not a point there because there's nothing to the left of that starting point of my graph. So like at the point 3, there's not a y value because there's no graph when x is 3. There's nothing there. So I want points after that. I see the point 5, 3. And I need another point because I need 3 points. 6 is 3.414213562. I don't want to try to graph that. That sounds like a pretty hard point to find. I want a nice clean point. The point 8, 4, that works. So I'm going to go to 8, 4. And I really just need 3 points. So that's it. And then I'm going to graph it. So this was 4, 2. So 5, 3 is right here. And 5, 6, 7, 8, 4. And there's the graph of my f of x graph of f of x. and I label it f of x. I labeled that table f of x. And then I need to get the inverse. So the inverse is f inverse of x. So inverse is just a -1 exponent. And the inverse graph is a reflection across the line y equals x. So I'm also going to add the line of reflection to my graph. It's the line y equals x. It's just a slope of 1, and it's positive, y equals x. It's the diagonal line that goes across the whole thing. This is y equals x. And that is the line of reflection. So my inverse graph is going to be the blue graph reflected across that red line. But to find it, the points, you can just, I suppose, do it just by looking at the graph, but that can sometimes be tricky. The best option is to do it with your table of values. From the original function, you take all the y values, and those become your x values. So I didn't have one, and it's a dash, so I don't really need that. So then 2 becomes the x value 2, the 3, and the 4. That's my new x values, and I take the y values, and I take the x values from the blue one, and they become the y values for the green one. So then 4, 5, 8. Now you can do them one line at a time, say 4, 2 is 2, 4, 5, 3 is 3, 5. But every time I do try to do my points that way, I end up messing one of them up by not flipping it. I find it much easier just to take the y values and make them the x values, and then the x values become the y values. So, and then I have points. That's all I have to do to find the points, is just flip the table. So 2, 4 is right here. And then 3, 5, and 4, 8. So there's the new values, and then I draw the curve. And that is f inverse of x. And you can see it's reflected across the red line. So that is how you find the inverse graphically. And that's for all functions. It's not just for the square root function, but it's for any function that you're given. If you need the inverse, graph it, swap the x and y values, graph the new table, or graph the new function. All right, so look at another one, number 2. Again, it put the -3 in the front. I don't like it when it does that. So I'm going to move it. I'm not solving anything, so there's no signs changing. I'm just rearranging it. I'm moving it to the end. So f of x equals the square root of x minus 1, and then minus 3 at the end. So now it matches my transformation equation. I have x minus h. So the 1 is my h value, and it's going to move to the right 1 space. That's h. So h is 1. -3 at the end, that's the k value. So it's going to go down 3 spaces. K is -3. That's going to be the starting point of my original f of x function. 1, -3. But I need some more points. You get those points by evaluating the function, plugging in values of x to get the y. You can use Desmos to graph it and find the points that you want to use. Or I like to use the table in the TI calculator. And if I do that, I type in y equals square root x minus 1 minus 3. And then second graph, and it'll give me a table of values. So I see everything above x is 1, so x is 0, and everything above that, there's nothing there. So that verified that I have the right starting point. And then 2, -2, that's my next nice point. And then 5, -1. Now occasionally there won't be they won't all be whole numbers for your y values, but it'll at least be something like 3.5. I can graph 3.5. I can find halfway to the next box. It's just when you have one of those really long decimals, you don't want to use one of those. All right, so 1, -3, 2, -2, 3, 4, 5, -1. You can also graph it by after you get the table of values, just hit the graph button and see what the graph looks like and make sure your graph matches the one on the calculator. And then I have a line of reflection. The line y equals x. I do need you to graph the line of reflection. That is part of it. On the test, it'll be like a point or two just if you have the line of reflection on your graph. So this is the line of reflection, y equals x. Oh, I didn't label my graph. I need to do that. This is f of x. And it's important to label the graphs also so I know which one is your original and which one is your inverse. All right, so now I'm going to get the inverse graph, so I need the inverse table. F inverse of x. So all the y values of f of x become the x values of f inverse of x. So this is -3, -2, -1. And then the x values of the original are the y values of the inverse. 1, 2, 5. And then plot the points. 1, 2, 3, and up 1. Left 2 and up 2. Left 1 and up 5. There's my new points. And then after you graph it, you should be able to see that looking from the line of reflection, it's the same on both sides. And there should be equal space between those two. So this is, from this point, it's down to over 2. So yeah, they match. All right, that's finding the inverse graphically.
So how do you know finding your points? How do you know getting your points?
In the TI calculator, do y equals, type in the function, and then second graph will give you a table of values. And you just go find 3 values that you like. You can do it in Desmos, but they're not going to give you a table. If you do it in Desmos, you have to look at the graph and find the ones that are exact points. I think it's easier to use the yellow calculators for this, which Algebra 1 has them today. All right, and then I'm going to go ahead and skip number 2 so we can have more time on the algebraic method on the back, but we do need to look at one of them that is squared. So those were both square root graphs, which is half of a parabola, right? We've already discussed that. This one is squared. So the inverse of a quadratic is a square root. So we should end up with a square root. Okay, so that's already in the correct order. I just need to graph it. So this is going to be my f of x values. Again, you can get HK. X minus 1 means you're going right 1 space, so h equals 1. The k value is -2, so it's shifting down 2 spaces. K equals -2. So 1, -2. There's the vertex. Now, on a parabola, on an x squared, on a quadratic, your graph is a parabola, so it does go to the left and to the right of your starting point. So I want to get that point in the middle. So 1, -2 in the middle. And then get the rest of the points. So I get them the same way. Y equals, type in the equation. And then second graph to get a table of values. Find where the vertex is, and you want to get 2 points above and 2 points below. So on my calculator, it gives me 0, 0, -1, 6, and then below, it gives me 2, 0, and 3, 6. All right, so then 0, 0, and negative 1, 6. 1, 2, 3, 4, 5, 6. So that's the left side of the graph. And then the right side, I have the point 2, 0 and 3, 6. So it gives me a parabola. And that's the graph of f of x. I'm going to put the line of reflection. All right, so that's the line of reflection, which is the line y equals x. And then I get the inverse, the table of points of my inverse graph the same way. All the y values become x values, 6, 0, negative 2, 0, 6. And then the x values become y values, negative 1, 0, 1, 2, and 3. So there's the table of values for the inverse. So 6, negative 1. It's right there. And then 0, 0. Negative 2, 1. Show what you pass. And then 0, 2. And 6, 3. There was 6, 3. And then connect the dots. So you can see now, if you reflect the parabola, that's what you get. And if we ignored the negative part, it would look just like the graph above. So again, number 4 was you started with x squared. So you have the entire parabola, it reflected across the line, and you have another entire parabola. But on 1 and 2, you started with the square root of x, so you only had half of the parabola to begin with, and it was the red, like on number 2 is the red one. You started with half a parabola, and you reflected it, so you only got half a parabola. All right, so that is finding the inverse graphically. On the back, we're going to find the inverse algebraically. And again, this works exactly the same no matter which function you're doing. There's some steps: switch x and y, solve for y, and label with inverse notation. My notes for this are swap and solve, which is the same thing as what's listed. I feel like swap and solve is a little easier to remember. To find the inverse of any function, swap and solve, which is kind of what we just did in graphing. X's and Y's trade places, and then graph it. So now it's X's and Y's trade places, and then solve it. So you're swapping X and Y, and then you're solving for Y. Okay, so before we can swap and solve, or swap x and y, looking at number 1, there's not a y, but there is an f of x. So we're just going to turn f of x into y. And now we can swap x and y. So wherever they are, they just trade places. You're swapping them. So now it's x equals the square root of y minus 2 plus 3. Once x and y have traded places, then you solve for y. To solve for y, I start with subtracting 3. So x minus 3 equals the square root of y minus 2. I want to get rid of the square root. So to do that, I am going to square it. If I do it on the right, I have to do it on the left. So I put x minus 3 in parentheses and square it. Now the nice thing about this is I don't need you to multiply that out. Because you're not solving it. I mean, I guess you're solving for y, but you're not solving an equation to get a solution. I just want you to rearrange it. So you don't need to multiply that out. You can leave it as x minus 3 squared. In fact, that's simpler terms than if you expanded it by multiplying it out. So that's better. So now I have x minus 3 squared equals y minus 2. And then the last step is to add the 2. So x minus 3 squared plus 2 equals y. But I can't call it y because I already said that this at the very top was y. This is y, so I can't call two things y. So I need a new name for this, and so I'm going to call it y inverse.
So you just put like a negative 1 by it.
Yes, so I'm going to put a negative 1 as the exponent. That means y inverse. Or you might see it as f inverse of x. Those mean the same thing. Either notation is fine. And you're done. That's the inverse equation. You started with a square root problem. You ended with a squared. So the inverse of the square root is squared. Or vice versa. If you started at the bottom, you'd have a squared equation. The inverse of that equation would be the square root. Let's look at the second one. First thing we're going to do is turn the f of x into a y. And now I can swap x and y. So x equals 2 square root of y plus 3 minus 1. And now I want to rearrange it to get y by itself. So I'm going to add 1. So x plus 1 equals 2 times the square root of y plus 3. And anytime you end up with a binomial, x plus 1, they're now joined together. A plus or a minus sign connects those two numbers. You can't split them up. You can't change them unless you change both of them. So go ahead and put them in parentheses so that you're not tempted to change them later. Now, on some problems, you may end up just like getting rid of the parentheses at some point. But that's easier than mistakenly just changing the x or the 1. It's a visual way to group them together and as a reminder that you can't change one without changing the other. So once you create a binomial on one side, go ahead and group them in parentheses as a reminder that you can't mess with just one of them. They're a set now. All right, and then keep going. So now I have 2 times the square root. So I want to divide by 2. You could divide by 2 or you can multiply by half. Either way, it's the same thing. I feel like on the right, yeah, I see divide by 2. But on the left, now I have this over 2, and that looks kind of weird. So I think it might be better just to go ahead and say multiply by half. But again, they're both the same thing. If you want to stick with divide by 2, that's fine. But I think it'll look nicer if I do multiply by half, because it's going to do the same thing. So I'm going to bring a half, say multiply by half. So on the left, that looks better than having it over 2, I think. So then I write it on the next step. Half of x plus 1 equals the square root of y plus 3. And again, that's the reason why I put the x plus 1 in parentheses, is because if I didn't, I might end up with half x plus 1, and that would be wrong, and it would throw the rest of it off. So again, the grouping it in parentheses is good. I'm not going to distribute the half, because I'm not expanding this. I'm not solving for anything. I'm just rearranging.
Where did you get the half from again?
I said divide by 2, and then I put it over here, and it didn't look very nice. So dividing by 2 is the same as multiplying by half. So I got the half by canceling out the 2. I used it to cancel it, and then I wrote it over here. And then I want to get rid of the square root, so I'm going to square it. So I need to square everything over here. So this is a little tricky. It's a place to make a mistake. So I'm not just squaring x plus 1. I'm squaring all of it. So when you square a fraction, you square the top and square the bottom. So 1 squared is 1, 2 squared is 4. So this is 1/4. And then x plus 1 squared, I'm just writing like that. And that equals y plus 3. I need one more step. I need to subtract the 3. So 1/4 of x plus 1 squared minus 3 equals y inverse, or f inverse of x. I don't care if you use y inverse notation or f inverse of x notation, but you do need to be able to recognize both of them. I'm not sure which one will be on the test. It might be both for different problems, but they mean the same thing. Okay. And then one more. Oh, no, there's a few more. So then number 3. Same thing. F of x is a y. And then x and y are going to trade places. There's just a few more steps in this problem. And you got to make sure you start with the correct number. So I'm going to start with the 2. The first thing I'm going to do is that's a positive 2. And then negative half times the square root. So that's why I'm not doing that one yet. I'm going to start with the 2. So I'm going to subtract 2 first. So x minus 2 equals negative half square root of y minus 3. So I said x minus 2, that's a binomial, so I'm going to go ahead and group it in parentheses. It's a set. I'm not going to break it up. I'm not going to change it. It's going to be x minus 2 forever now, at least for this problem. All right, so now I want to get rid of the negative half. To get rid of a number in the denominator, I need that same value in the numerator, so 2, but it's negative, so I want to multiply it by a negative 2. So if I multiply the right by negative 2, it cancels out the negative half. If I do it on one side, I have to do it on the other side also. So now I have negative 2 times x minus 2 equals the square root of y minus 3. Again, I'm not distributing on the left. I'm leaving it like that. My My goal is to get y by itself, so I need to get rid of the square root, so I'm going to square it. Again, I need to square everything on the left. So I'm squaring all of it. So I'm going to square the negative 2. Negative 2 times negative 2 is positive 4. And then the binomial I'm going to leave written as x minus 2 squared. But make sure that you get both pieces there and the parentheses. Equals y minus 3. And then the last step is to add the 3. So 4 times x minus 2 squared plus 3 equals y inverse, or f inverse of x. So we started with a square root equation, and we ended with a squared equation. That's a way to verify that you got the inverse, that you have the inverse operation happening. All right, so all of those we started with a square root and ended with squared. But we could also start with squared, and if we start with something squared and we're finding the inverse, we're going to end with the square root. Which I'm going to go ahead and just do number 6, but I'm going to change this one. Yeah, I want to make that a 4. I feel like this would be a much better problem if this 2 was a 4. Okay, so I'm changing, here, let me just do it this way. I'm going to change this. I'm going to make it f of x equals 4 times x plus 1 squared minus 5. Okay, and then go from there. So f of x is the same as y, and then I need x and y to trade places. So x equals 4 times y plus 1 squared minus 5. So this is a squared problem, so my result, my inverse, is the square root. I'm going to end with a square root equation. Alright, my first step of rearranging to get y by itself is to deal with the 5 on the end, because I have 4 times parentheses and then minus 5. So I start with the minus 5. I'm going to add 5. So x plus 5, oh look, there's a binomial, so I'm going to group it, equals 4 times y plus 1 squared. Alright, now I have 4 times y plus 1 squared. So I want to get rid of the 4. To move the 4, I'm going to use 1/4 to cancel it. I want to cancel a 4. Bless you. So I'm going to use 1/4. There's 4 over 1/4. 4 times 1/4 is 1. If I do it on one side, I have to do it on the other. So now I have 1/4 times x plus 5 equals y plus 1 squared. Trying to get y by itself, so I need to get rid of squared. So I'm going to take the square root. That's how you cancel out a squared, is you take the square root. If I do it on one side, I have to do it on the other. Alright, so I need to take the square root of the 1/4 and the square root of x plus 5. That's why I changed it to a 4. Because when you take the square root of a fraction, you can take the square root of the top and the bottom separately. So the square root of 1 is 1. And the square root of 4 is 2. So the square root of 1/4 is 1/2. And then square root of x plus 5, I'm just leaving like that, equals y plus 1. And then my last step is to subtract 1. So I have 1/2 square root of x plus 5 minus 1 equals y inverse, or f inverse of x. So on this problem, I started with x squared, or a parentheses squared, and I ended up with the square root.